All right, let's dive right in. We're going to talk about something that impacts pretty much everyone, math class. With artificial intelligence changing our world so fast, it forces us to ask a really big question. Is the math we're all learning in school still the right math for the future? Let's figure it out. I mean, this is the question, right? It's on everybody's mind. You can type a super complicated problem into a machine and bam, the answer pops up in seconds. So it's totally natural to look at that and think, why am I spending years learning how to do this by hand? It kind of feels like we're training to be human calculators in an age of supercomputers. And the answer to that question is a huge, definite yes. We absolutely still need math. In fact, you could argue it's more important than ever. But, and this is the part that changes everything, the kind of math that really matters is different now. The goal isn't to beat AI at crunching numbers. It's to learn how to think with AI, to use mathematical ideas to ask questions and frame problems that a machine could never come up with on its own. Okay, so here's our game plan. First, we'll look at the new challenge AI brings to the table. Then, we'll see what other countries are doing about it. We'll pinpoint the specific math skills we need for the AI era, figure out how we can actually make space for them in the classroom, and then wrap up with a new way of looking at the value of math. So, let's start with the challenge. Look, technology has always forced schools to change, but AI isn't just another small step. It's a giant leap. For a long time, being good at math meant being fast and accurate with your calculations. Well, those skills are now completely automated. The real problem is that our curriculum hasn't quite caught up yet, leaving this growing gap between what we're teaching and what the world actually needs. And this isn't just some theory, you know? If you look around the world, there's this quiet but really important reform happening. Major countries are already rethinking what a modern math education should look like. And you can see a super clear pattern just from the last few years. In 2023, California pushed to strengthen data literacy and modeling. Germany's 2022 standards are all about modeling and data application. Japan is focusing on data utilization. Now, Taiwan's 108 curriculum was a good step, but seeing how fast the world is moving toward data and application, well, it definitely creates a sense of urgency for us to keep up. Now, let's be really clear here. This doesn't mean we just throw out algebra or geometry. The core topics are still there. The real revolution is in the emphasis. We're shifting away from just solving abstract problems on a worksheet and moving toward using those very same mathematical tools to understand data, build models, and make sense of the real world. So this brings us right to the heart of it. If we want to get students ready for a future powered by AI, we have to ask, what's the math that actually makes these amazing technologies work? And, more importantly, how does that compare to what we're teaching right now? Well, it turns out the engine of modern AI basically runs on three key mathematical fuels. First up is a linear algebra. That's the math of vectors and matrices, and it's absolutely essential for handling huge amounts of data. Then you've got probability and statistics, which is how machines learn from data and deal with uncertainty. And finally, optimization, which is all about finding the best possible solution, a core part of training any AI model. These topics might get touched on in high school, but they rarely get the starring role they really deserve. And this right here really shows the disconnect. On the one hand, our traditional curriculum is great at training students to do complex calculations by hand and to work through abstract proofs, and those are valuable skills. But on the other hand, the AI era needs people who are great at mathematical modeling, who can interpret data, and who can apply math across all sorts of different fields, from science to finance to art. So, the big question is, how do we make this happen? It sounds like we have to just keep cramming more and more into an already packed school day. But the answer isn't just about adding more stuff. It's really a careful rebalancing act, a little bit of addition and subtraction to make room for what's truly important today. Okay, so what can we trim back a bit? And again, this is not about making math easier. It's about being smarter with our time. The rule of thumb is pretty simple. If a computer can do it instantly and perfectly, we should probably focus less on the manual labor and more on the concept behind it. That means maybe a little less time on super tedious polynomial calculations or memorizing really complex trig identities. Because by trimming some of that, we open up all this amazing space for the skills of the future. We can beef up data science so students learn how to actually work with data. We can give linear algebra the spotlight it deserves and show how it's used everywhere. And we can build whole courses around mathematical modeling and really connect math with programming in other fields. Now, we've used this phrase mathematical modeling a bunch, so let's just make sure we're all on the same page. Think of it like being a translator. It's the art of taking a messy, real-world problem, like, say, predicting traffic patterns, and creating a simplified mathematical version of it so you can actually understand and analyze it. The whole point is the application, not just getting the one right answer. And all of this brings us to our conclusion. The whole reason we teach math is changing. We need to shift our goal from training students to be amazing human calculators to empowering them to be creative, flexible problem solvers who use math as their ultimate tool. This quote just nails it. The future of math education, whether in Taiwan or anywhere else, isn't about choosing one thing over the other. It's about balance. We still need a foundation in calculation, of course, but that has to be combined with modeling, with data science, and with the kind of algorithmic thinking that truly runs our modern world. So let's just say it one more time to be perfectly clear. The rise of AI doesn't make math obsolete. No way. It makes it absolutely essential. Its value hasn't gone away. It has just evolved. It's shifted from the what, the final number, to the why and the how. Why does this work? And how can I use this idea to solve a brand new problem? And that really leaves us with a final question to think about. When we're designing education for the next generation, what's our ultimate goal? Are we trying to train students who are just really good at doing calculations? Or are we trying to cultivate future innovators and leaders who are really, really good at using the powerful language of math to understand and shape the world around them?